Okay, I guess you can see my screen and hear me okay. I got one shout out. Let me bring up the chat window just in case. Somebody can let me know if I'm live and in person here. That would be helpful.
Yes, you are.
Great,
Hi.
thank you. All right, super. All right, let's go ahead and get started. Welcome to week 4 of CYBV 473, the Violent Python class. And let's kind of walk right through the briefing real quick, and then I'll get into some demos and we'll we'll knock this out in short order. So we're going to talk tonight about the Python image library mainly. I'm also going to kind of give you a little bit of more detail on the pretty table library, which is something we use quite often to kind of pretty up our displays and the information that we're going to provide. So again, as usual, kind of review the walkthroughs and the from the previous week, and also, obviously reviewing the webinar tonight. And basically, there are several scripts within the D2L week 4. Make sure you load those in and step through those. That'll give you a lot of background on what we're doing from that perspective. So I'll do a solution script demonstration for week 3, but I wanted to go over 2 quiz questions that troubled me a little bit. Excuse me. And several students got these 2 wrong. Most of the other ones everybody got right, or maybe 1 or 2 people got them wrong. But this one, the following is a valid function declaration defined by function a comma b. All functions, just like if statements or for statements or while statements, need to end in a colon. So this one doesn't have the colon to define that was the end of the function. The second one was all Python functions must return a value and you must pass in at least 1 argument. Not true. You can have a Python function that doesn't require any arguments and doesn't return any values. So they can be very flexible. There was a couple other questions in the set that kind of addressed that people did better on, but just so you know that they're not necessary. So with that, let me jump into the week 3 solution. So I'm going to actually walk through this one. Sorry, I've been on the phone all day today with a variety of meetings, so I'm kind of losing my voice. I apologize. Anyway, let me walk through this from the beginning, and I'm going to actually set a breakpoint right here in my as we start the main loop of my solution script. I'm just going to set a breakpoint there. I could have put a main section here. It's not required. If you have a script like this, you can use it or you don't. All it does is allow you to basically decide that, hey, this script has a main section, therefore you should be running it as a script versus importing it as a library. So remember, when you're developing Python scripts, you can design the script so that it does nothing, except it has functions or objects that you want to be able to import into other applications, just like we do with the standard library. So just kind of a quick thing there. Let me start the script and I will walk through this, make sure I'm doing the right one. Yeah. So this is the week 3 assignment. And again, I want to kind of walk through this step by step for you so you can kind of see how this works. So I'm just going to prompt the user for a directory to scan. You can pick anything you want. I'm going to say C:/test. I've got a bunch of stuff in that particular directory. You can have whatever directory you want to test with. I'm going to check to make sure that the user didn't enter Q to quit the script. If they didn't, we're going to continue on. Then the first thing I'm going to do is check to make sure, hey, did the user actually enter in a directory? So I'm going to use the os.path library to check to see if the path they entered was in fact a directory. It is in this particular case. If it wasn't, it'll post invalid directory and go back and ask them again. Right? Just kind of a nice little piece of code to copy for yourself. So when you want to ask a question where you've got to get a valid answer. So the next thing I'm going to do is I'm going to actually get all of the entries that are in that particular directory. I'm calling it file list for a couple of reasons. One, it's a list because that's what comes back. If I put my cursor over it, you can kind of see that it's a list. Some of these elements in the list are not actual pure files. Some of them are directories. Just keep that in mind. So now what I'm going to do is I'm going to iterate through that list. one of the great things about Python and lists and sets and dictionaries and strings, I can iterate over them and Python will let me know when I'm done because it basically will go through each one until it exhausts the list. So in this particular case, I'm going to get the first one, which is a possible file. And what I'm going to do, the reason I said it was a possible file, because it could be a directory. And what I'm going to do is I'm going to join that directory path that we started with that the user entered. And we're going to join that with the file name, because if you look at the file list, the only thing that comes back from os.listdir is the names of the entries in the directory, not the full path. So I want to get the full path, and I'm going to be even more particular and say I want the absolute path, even though I entered an absolute path. So now what I'm going to do is I'm going to call this class to instantiate the class with that absolute path. I want to basically say, okay, file processor, I want you to process this particular file. So I'm going to create an object from the class. What I'm going to do is I'm going to step through that method, which will be the init method of the file processor class definition. Remember, we're going to instantiate an object from that class, but I can step into that using, in my case, F7 in order to be able to do that. So now I'm going to actually enter the init method of that file processor class template. So the first thing I'm going to do is I'm going to basically take whatever path the user passed in, which in this case was c:/test castle.jpg. That was the first file that was in the directory c:/test. I'm going to put it into a instance variable named self.path. So all of the other functions within the object can access it. I don't have to worry about it anymore because the class has got it. So the first thing I'm going to do is check to make sure that, hey, is this particular entry that I've received here, this particular path, is it a file? And do I have access to it? If I don't, then I can't process this particular file. I have to know it's a file, and I have to know if I can actually have read access to the file, because I'm going to need to do that later. The next thing I'm going to do is I'm going to use the OSStat method in order to be able to notice I'm using the self.path variable here in order to be able to call OSStat and get some information about that particular file. Basically, the metadata that's associated with that file in the file system. So what I'm going to do there is now I can actually use that stats variable that I created and I can get a bunch of values. One of them is I can get the size of the file because the operating system and the file system knows the size of that file. I can now put my cursor over it and that's the size of the file. But notice that again, I'm setting that equal to self.file size. Again, I'm creating that instance attribute in the object. So any of the other functions like the print function we're going to use later could access that. Then I'm going to basically get the created time, the access time, the modified time. And again, I'm putting those in instance variables and I'm just using the time method in order to do that. I'm going to get the mode of the file, which is not that interesting on Windows, and I'm going to get the user ID. And then I'm going to create some space for the file header, just to basically make sure that all of our variables that we're going to use, the instance attributes we're going to use, have been initialized. I'm going to say status is okay. I can come back now to the, I've now created a file object based on that class template. And now I can check the status. You notice that up here, I actually set status to be okay. So in this case, I can say, hey, was the status okay? In this case, it is. So I can come down here and I can say, now I want to go out and I want to get the file header, right? So I'm going to use that file object that I just created, and I'm going to call the function of get file header. You notice that I don't have to pass any parameters to this except self, which basically gives it access to the instance attributes and the other methods that are part of the class. It knows everything else I need if I did it right, right? So in this particular case, I'm going to go ahead again and I'm going to step into this I'm going to use the F7 key this time so I don't have to go up to the menu. And I'm going to come here. So I'm going to have a try except to make sure everything goes right. First thing I'm going to do is I'm going to print out the path. So that's the path that I'm actually processing right now, c:/test/castle.jpg. I'm going to go ahead and try to open this. Now, the reason I have a try except around here is I might not be able to open that particular file. So I may get an exception, right? For example, unable to read the file. So in this case, I'm going to go ahead and say, open it. It was successful. If it wasn't successful, I would have gone to the accept, but it was. I'm going to read the first 20 bytes of the file. I'm going to use Hexify to make it pretty. I can put my cursor over that. Notice I'm actually using an instance attribute here called file header. And I'm going to basically say, hey, there's the file header. And again, I'm going to say self status is okay. I'm done. And I'm going to come back down here and I'm going to check to make sure that I was okay. If it was, I'm going to go ahead and print the file details. I'm going to call another function within that particular object called print file details. And notice again, I'm not passing any arguments because print file details should have all the information it needs to know about that particular file because that's its function to keep track of such things. So I'm going to hit F7 again. And now I'm going to print some of the output for that particular file. So I'm going to print out the file details. I'm going to print out the path, the size, the last modified, last graded, mode, user ID, header, and say OK again. And if I come down to the bottom of my screen, I should see an output for that particular file. Now I've only processed one file now in this particular directory that the user has process. So everything was okay. So I'm going to continue. And guess what? I'm going to get the next file or the next entry in the directory to be more specific. And I'm going to basically repeat the process. So I'm going to get the full path. I'm going to get the absolute path. And I'm going to create a new file object. I'm going to overwrite the other one. I don't need it anymore. So I'm going to basically say file object now equals an instance attribute, an object file processor with that absolute path, which is c:/test.cat.jpg. And then I'm going to do the same process. I'm going to go get status. I'm going to get the file header. I'm going to print the details and I'm going to go back to the top. But if I go down here to the bottom, now I've got the file details for cat.jpg and I've printed that stuff out. So the only thing that can go wrong here is what if I attempt to open a file? In this particular case, I go try to create this. And what if it wasn't okay, right? So there's several things that can happen of why it wasn't okay. So let's run the script and see what happens to see if we get any exceptions. I'm just going to actually go ahead and just run it. And so now it will have processed all of those files within that particular directory. And you notice I got an exception that this file was not accessible. I generated that exception for more and more too, because it's not a file. It's actually a directory there. So I can't process the file. It's basically a directory. So I get those exceptions here and all of the other files should work just fine. And I could basically go pick another directory and do it again. So that basically just iterates through all of the entries that were in that directory and it basically processes those. Now we have this really cool file processor object that we can apply to any file. And it'll basically give us back that information. So now this is kind of reusable. We could use this file processor object anytime we want in order to be able to get some basic metadata information from the file system about the files in any directory or any file for that matter that we want to basically utilize. Yeah, the lecture PDF will get posted. And I don't think I've enabled week 4 yet, so that's why you're not seeing it. So that'll come when I get to what we're going to do in week 4. All that stuff will be enabled later tonight, as well as this solution script will be posted. Remember, what I do with the solution scripts is I post them to the week that they were associated with. So I will post this solution script back into week 3, since we're on week 4 right now. So we will go through that. So any questions on the solution script for week 3? Again, I will post that for you so you have it. And if you had any difficulties with the script, what you should do is make sure that you do what I just did and step through this script and make sure that you understand all of the things that are in that particular script and how I approached it. The way I approach it is not the only way, as I've always said, but it is a starting point for you in order to be able to look at how I processed all the files in that particular directory using the file processor class, instantiating it in an object for each one of those. Any questions? Okay, cool. Let's jump back into the lecture then. So one of the key things within Python, I have a few slides here, so I will bring it up full screen for you. Within Python, we've been using mostly up to this point the standard Python libraries and not doing much with third-party libraries. But the ecosystem for Python, one of the real powers of it is not only the standard libraries that are available, which are pretty extensive, but also third-party libraries that are available that other people create. There's many of them. Virtually anything you want to be able to do, you'll be able to go find a third-party library that does it, or typically many third-party libraries that will do that. So that's one of the key benefits of the ecosystem for Python in order to be able to do that. So one of the questions you might have is, well, where do I find these? How do I research what third-party libraries exist and how do I actually process them? Everything you're going to need for this course is already built into the VLE for you. So you don't have to install any if you're using the VLE, but if you're using your own personal computer, you'll have to install those third-party libraries as we use them. So one of the things you can do is the main place that you go is pypy.org, which is the Python Package Index. That's what that stands for. Pretty simple interface. It has a place where you enter projects, and it'll give you a summary here. And right at the time that I took this screenshot, there's a lot more now. There were 189,591 projects. Over 2 million files, and there were over 351,000 users that were actually contributing to the Python Package Index. So you can imagine that there's a lot. One of the things that I use a lot in my practice is both the pretty table and the pillow libraries are two libraries that I use, where the pretty table library allows us to, pretty up our output a little bit, make tables really easily, sort those tables, that kind of stuff. The next library that we use a lot is called Pillow. Anytime we're doing anything with images, like you're going to do this week, you're going to use the Pillow library, which stands for the Python image library. And we're going to basically do that. So you can search for those. Again, you don't have to, because they're already built for you within the VLE. These libraries are already installed, so you don't have to install them. But if you need to install them, if you go to the pretty table library, it will tell you how to use pip to install that library. You just basically go to the Windows command line and type pip install pretty table, and it'll install that particular library for you. Now, you just have to make sure that you're using Python allows you to have multiple versions of Python running. So you have to make sure that you're using the version of pip that's associated with the version of Python that you're using. If you only have one installed, then that pip will associate with that version of Python, for example, 3.8 or 3.10, whatever you're using. If you happen to have two of them, like if you had Python version 2 installed and version 3, then you would do something like pip3 install Python pretty table that would install the library. So just got to get used to the fact that you can have multiple instances of Python on your machine that are different versions. And then there's a description, there's download files, release history, there's a home page that you can go to find out more information about these libraries. Just want to kind of show you that just so you know where you can go. If you want to basically install the Python image library, again, you don't have to do that for the VLE, but if you wanted to do it in your own machine, it would be pip install pillow, and then you would have the Python image library on your own machine to basically experiment with that. So we can experiment with pretty table. And some of you have already done this. Some of you have already explored. In the last assignment, I noticed several folks in week 2 haven't reviewed week 3 yet, but in week 2 basically went through and actually created pretty tables in order to do this. It's relatively simple. Once you import the library, all you do is you say my table, or whatever you want to call your version of the table. You're creating a new object here called my table in this particular case. And it requires you to pass in a list of the columns of that particular table. And then you could add rows to that table. And the only rule is the row to that table has to have the same number of entries as the original list. And you add the row as another list. And so then if I print out the table, I basically get file name, which was the column name for the first column, and picture.jpg goes here, and it creates a pretty box around it. So you have kind of a really easy to read output from Pretty Table. You can add several rows to the table. So this is kind of a good hands-on exercise for you. Now that you know how to do that, go into, this is one of those places where you have an opportunity to play around within the environment. You can do this right within the Python shell. You don't have to write a script. You can do all this just like I did here. You can see I was working in the Python shell when I did that. It's a great way to kind of experiment with new libraries to kind of get a feel with it before you start to integrate it into your actual scripts. So just kind of a tip. The next thing we're going to do is we're going to experiment with the Python image library, which is a little bit more complicated. But again, once you've installed, or it's already installed in the VLE, you can again come right here to the Python shell and you can start to experiment with it. So for example, in this case, I'm going to bring in the image function, the image module portion of this library. So I'm saying from pill, import image, and then I can say pill image. I'm going to create a new object, which is going to be a pill image, and I'm going to open the file test.jpg. If that is successful, there's a couple of key things you know. Number one, if that line is successful and we don't get an exception, then we know that that particular file is in fact existing and it's an image. It may not be a JPEG, it could be a PNG or a BMP or a GIF or whatever, but it's going to be an image. If it's not an image, you'll get an exception. It's really important what one of the assignments you're going to do. You're going to use that knowledge that, hey, if I attempt to open using the image module, if I try to open a file and it's not an image, I'm going to get an exception. Is kind of a key point. And then you can go down and see all the different things that you can do, just like with other things like the OS library that we've already used. You press exif data dot and it'll show you different elements of that. So I want to kind of walk through some scripts for you now, just to kind of give you an idea. We'll do something really simple. We'll do just a quick pill demo here. Let me clear the output area for you. And these are, all these scripts are in the in D2L for you. So when I enable week 4, you'll be able to go through and step through this. And that's what you should be doing, just to kind of get a feel for how these work. So in this particular case, I'm going to actually step through this script line by line. And again, these are structured in a really simple way. So I'm going to come here, I'm going to open the OS library, and I'm going to use the exact what I showed you in the briefing. I'm going to say from pill, import image. When I do that, I'm going to now have that image library, image module available to me. But the first thing I'm going to do is ask the user, well, give me an image that you want me to process. I think I have one in this directory called barn.jpg. And what I'm going to do is, that's what I've entered. If I did it right, and there's one there, if I attempt to open that image file as image, so I'm going to say with image.open image file as IM. So IM is going to be the object we're going to create if this was successful, and it was. So that means that if I put my cursor over this, it says, oh, this is a photographic image. It's RGB, that's its size. In other words, it's dimensional size, 620 by 469 in pixels, and that's where it's located. So you immediately know, if I've done this, hey, I've actually got an image. And now what other information can I glean? Well, I can set the status that, hey, that was an image. Then I can actually get the format. So I can say im.format, and it'll give me the format. And oh, look at that, it's a JPEG. What a surprise, since I typed in barn.jpg, but it does not get the image type from the extension. It gets the image type by looking inside the image and determining what it is. Then it's going to give me the type. If I look at the type, it's going to be RGB. So basically it's a red, green, blue, full color image. It's also going to give me the height and the width. So I can get those in variables. So it's 620 by 469, and then I can print that information out. So now I have some information about that particular image, barn.jpg. I know that it's a JPEG, I know it's RGB, and I know the width and the height. And I can do a lot more, but that's just kind of the basic how you structure this in order to be able to get information about an image. And now what we're looking at here, remember, is we're looking at the metadata of the image itself, not the metadata that's associated with the file. In other words, the file system metadata. We're looking at the actual inside of that image in order to gather that information, and the Python image library is doing that for us. Any question on that before I go into a little bit more complicated demonstration of the tags that we can pull from a JPEG? You guys still there? Can you hear me?
Yes, I can hear you.
Okay, great. Thank you. Just so I'm not talking to myself here. All right. All right. So that's kind of the first quick demo. Again, this script will be in the shell in the D2L environment in week 4 for you. So you can do just what I did and step through this and try it out. So let's actually go to the second demo that I put together for you, which is the demo of tags. Now, understand JPEG images have tags, and they have many of them. There are over 3,000 defined tags that you can have within a JPEG. Now, most JPEGs don't have that many, but you can actually have many different tags that provide other information about the particular image embedded in that particular file. It's in something called EXIF data that's associated with that particular image. So let's actually step through this script and see how we actually gather information about the EXIF tags that are stored inside a JPEG. So in this case, what I'm going to do is I'm going to do just what I did before from PIL import image. So I'm importing the image module from within the Python image library. Okay. And I'm also going to import a couple of key things. I'm going to say from pil.exif tags, and I'm going to import the tags and the GPS tags because there's a couple different tags. If I want to look at those, we can kind of see that, oh, this is kind of interesting. This is a dictionary. So tags are a dictionary, and it has a key and a value. So 1 is the key in this case, and intro p index is the value. Processing software is another value. News file type, and so on and so forth. So each one of these tags has an associated with it. For example, image width or image length, or bits per sample, compression, all of that information are the possible tags that are within an image. Like I said, not all of them have all of the tags, but that is the list of the complete list of the tags that are there. So again, let's go ahead and say, hey, I want to process a particular image, and we'll go back to barn.jpg. Once again, I'm going to try to open it, but this time after I opened the image and it was successful, I didn't get an exception. It opened the image just fine. And again, I can put my cursor over a PIL image and get some basic information. Say, yeah, it is a JPEG, and that's what it looks like. So now what I want to do is I want to get the EXIF data. So I'm going to use the PIL image, okay, that I just created, and I say I want to get the EXIF data. So that's going to give me all the EXIF data that's associated with this particular image, and it has all kinds of values in it. So how do I actually deal with this? So there's a few that I'm looking for in this particular case, so I can just be reasonable about the ones we're going to pull out. I want to know what the image timestamp was. I want to know what the camera model was and the camera make. So those are 3 that I'm looking for. So now what I can do is I can say, is there any EXIF data? Because remember, I actually brought in EXIF data here, and yes, there is some. So if there wasn't, if it was empty and there was no EXIF data, right, just like other things in Python, it would return a Boolean would be false. In this case, it returns true because there's something in that data. So now what I can do is I can iterate through each tag and the value that's in that dictionary. So all I'm doing, remember, key value pair, I'm iterating through the key value pair of the EXIF data that I extracted from this particular image. We've done this before, but not with an image. So now we're looking at the tag and the tag value. So now I can actually get the tag and the tag value, and I can see what it is. Oh, that one was GPS info. I wasn't looking for GPS info in this particular example, but you will in your assignment. So keep that in mind. So if the tag is date time original or make or model, I was interested, but guess what? It's none of those. So let's set a breakpoint here so we don't have to run through all of the EXIF data that we weren't interested in. Let's see if I run this script now, if we get any of the breakpoints, in other words, we get the tag values that we were in fact looking for. So we did. So I hit go, and the first tag value that we came up with was make. Right? So now I have the make of the particular camera. So I can create a variable called camera make, right? We put up here initially set to not available. And I'm going to say EXIF data get tag. So I want to basically get the tag, and the tag in this particular case is the number associated with the value of tag value of make. And then what I can do is I can extract the contents of that tag. And if I put my cursor over this, the make of the camera that took this photograph was a Nikon. So that was what was embedded in the EXIF data associated with this particular image. Let's do another one. Let's say go again. Now we found the model. So in this case, I found the tag value of model, right? That's what I was looking for. And now I can actually get the model data from that particular camera. And if I put my cursor over it, it was the ColorPix P6000 was the camera that took that. If I do one more time, this time we got the timestamp. You notice we skipped over all of these because there were more tags in this particular image. I wasn't interested in any of those in this example. I was only interested in timestamp, camera make, and camera model. So in this particular case, I'm going to get the timestamp. So now I can put my cursor over timestamp, and I get the time and date of when this particular photograph was taken according to the camera that took it and according to the data that's in the EXIF data of the camera. Now understand those can be manipulated, but nonetheless, that's what is in the EXIF data of this particular JPEG right now. That's going to be all that we're going to get. So I'm going to clear these breakpoints, and I'm just going to say go. And now I can print out the timestamp, the camera make, and the camera model in that one. So here's another great little demonstration you can use. This script also is in your in the D2L week 4 for you to actually walk through and experiment with. Any questions so far about what we're doing with the Python image library in order to extract the metadata that's associated, specifically the EXIF metadata that's associated with JPEG files and those values that are contained within the image? So far, so good.
Yes.
Piece of cake. We're good.
I have one question.
Sure.
You mentioned it was just for, is it just for JPEG files, or you'll be able to get the PNGs as well?
PNGs, BMPs, GIFs really don't have any they don't have EXIF data in them, so this won't provide that for you. If there are other file formats that do have this kind of metadata, but the most popular one is JPEG, which has, again, thousands of different tags and values that are associated with the image that's there, what you're typically going to run into.
Thank you.
Mm-hmm. Okay, so assignment 6. So in this particular assignment, there are 2 assignments this week. Let me go to the assignments real quick to kind of show you what they look like. And you'll see that basically what I've provided you with is the examples is kind of the baseline of what you're going to need in order to solve this week's assignment. No, wrong way, sorry, content week 4. So again, I haven't exposed week 4 yet, but all those files that I told you about are here. pill demo, the Python, the pill demo tags is here, the barn image is here, so you can repeat exactly what I have. I've already also provided you some test images that you're going to use. So when we're going to be doing 2 assignments this week, assignment 5 and 6, assignment 5 is searching for digital images. So what you're going to do in this particular case is you're going to extract the test images that I provided, and you're going to develop a script that prompts the user for a directory path to search, which will be the where the files are that are contained within test images, that zip file. You're going to basically unzip that and put it into a directory. Verify the path of the directory exists. You're going to iterate through each file in the directory and examine it using the Python image library. And you're going to generate a pretty table report of your search results, an example shown here. So basically, the first column is going to be whether it was image or not. There may be files in there that are not images. Remember how to tell if I attempt to open a file with the Python image library using the image method. If it doesn't open, I'm going to get an exception, and then that would be no. But otherwise, it would be yes. That would be the file path. That would be the file size. That would be the extension. That would be the format of the file that comes back from the Python image library, the width, the height, and the type. All those things are actually coming from the Python image library, with the exception of the extension of the file. You'll have to extract that yourself. There's easy ways to do that. And then you're going to apply the script. So this first one is really easy, sort of, because all you're going to do is basically loop through each one of those files and determine if it's a file. And if it is, you're going to get some basic information, the simplest information we can get from the Python image library, specifically the format, the width, the height, and the type. I forgot who asked that question. I think it was Teresa. So in this case, this will work for any file, any image type. So if this was BMP or GIF or PNG, whatever it happened to be, all of this data will in fact be available. You notice that one of these files was a PNG, right? So that level of metadata inside the file is available from the Python image library because it's contained in all images. The second assignment is a little bit more complicated, and I'm going to show you how that, I'm going to show you that within the example. Anybody have any questions yet about what you're doing for assignment 5 before I kind of jump into what you're going to be doing for assignment 6? Okay, so in assignment 6, we're going to be extracting more information, but I've provided most of the functions that you're going to need in order to extract this data. So you're going to, again, provide a path to the directory of JPEG files that I provided you. And for each one, you're going to extract the GPS coordinates for each JPEG if those coordinates exist. Not all the JPEG files might have coordinates. So one of the cool things that are part of JPEG files, if the camera took the photograph, it will give you, and that feature was enabled, that particular JPEG file will have EXIF data in it that will give us the latitude and longitude of that particular photo at the time that it was taken, and then the timestamp, and then the make and the model of that. So you're going to create a pretty table output that will look like this. Finally, you're going to map the GPS coordinates along with the file name. So there's a website out there called mapmakerapp.com. And you can either manually enter the lat long values in your script, or you can generate a CSV file and upload that into the data. So you need to go to https mapmakerapp.com and learn how to use that online resource to be able to map the images. So in this particular script, like I said, I've done a lot of the heavy lifting for you. In this particular script, where I get the latitude, longitude, I converted latitude, longitude that are in EXIF data is coming back as degrees, minutes, and seconds. And almost all the resources online don't take degrees, minutes, and seconds. Rather, they take the decimal version of that. So I even provided the conversion function to do that for you, and then kind of give you an example of how to actually do that. And this script will do that. So now you're going to basically do this for each of the files, in this case, I just basically did it for target file. You're going to do it for all the files in that directory. So you need to create a loop. And let me see if this it might not run because I think you have to add some code to this one. Maybe it will. Yeah, it does. So in this particular case, it showed all of the GPS info that was for bind.jpg. It gave you the timestamp, the camera make and model, and it calculated the latitude and longitude from that particular JPEG. So this gives you everything that you need, except that you have to basically do this in a loop and then create the pretty table output as I've kind of defined here at the top. And your pretty table should look something like this. You may left align yours versus centered line, whatever, but that's what you're going to end up doing with this assignment. So all of the functions are here. I provided an example here that actually works. So it'll actually, in the main loop here, it will use all of those functions. So what I would highly recommend with this before you try to tackle this is to step through this script line by line and make sure that how I derived all of the data that is going to end up being in your pretty table in this particular example. And then you'll have to figure out the map maker to be able to post those to the map. So that's your assignments for the week. And basically dealing with images is something we do a lot in order to be able to identify those images. When were they taken? What's the content? Where were they taken? There's all kinds of information. So dive into this and have some fun. The Python image library gives you a lot of information about how to do this. Any questions about the more complicated assignment that, again, is based on the two examples that I gave you, and obviously the starter script here for extracting the data that you need? So this is a really good assignment to basically kind of dive into extracting detailed information from images. Like I said, there's over 3,000 different possible tags that are available for JPEG images. Any questions? You guys are awful quiet tonight. Is this overwhelming, or is this really simple, or is there anything here that's like really confusing? Just tired? I'm tired. I don't know about you guys.
Seems pretty straightforward, if I'm honest.
Cool. Good. Anybody else?
No, just wanted to say that no, it's not that difficult, but it's just getting a little bit more complicated over time. But with your explanation and the examples, I have been able to complete the assignments, and so far so good. So thank you.
Yeah, no problem. Again, the whole point of this class is it's really hands-on. So I try to provide you with enough sample scripts that you can step through that really give you an idea how to do these different things to extract this data. And we're going to do a lot more throughout the semester. But the best thing that you can do is jump into the environment, step through the scripts, examine variables, add some print statements if you want to print out things that you want to see what they are, and kind of, interact with the samples that I'm giving you. And then that'll basically help you with the flow. I see most of the problems people are having tend to be with flow. In other words, how do I indent? What do I have to do inside the for loop, or inside the while loop, or inside the if, that kind of stuff. So this gives you a lot of examples of that. So you can kind of see how the scripts are structured in order to be able to carry out the lines of script within either the if statements or the while statements or the for loops in order to do that, and how to do iteration across variables like that. Probably the most complicated thing here is, in fact, doing this iteration over the EXIF data. And the reason that it looks more complicated than it is because the EXIF data that comes back is a dictionary. And we know how to, when you step back and say, okay, what is this data type? Well, it's a dictionary. In order to iterate over it, I've got to get the tags and the value for each of the items in the dictionary, right? So that's probably, and then be able to process each one of those tags and values, within the loop. So a lot of it that I'm seeing where people are having some struggles, most people are doing really well, but having struggles, it's about how do I make that structure and flow of the script in order to be able to iterate over items, whether they be dictionaries or sets or lists, whatever they happen to be. So you're doing exactly the right thing and stepping through the sample scripts and making sure that you understand how those work and then add the additional. So these starter scripts really should give you a head start on how to actually, process these. And again, remember, Python tutoring session is on Saturday morning, 8 o'clock Arizona time, and then the office hours are at 6 o'clock on Monday afternoons. Well, actually 4 o'clock for you guys on Mondays to bring questions, whatever. And remember, use the discussion thread to post questions that you think might be relevant to other students. I'll respond to those or post new videos, that kind of thing, to make sure that you have an understanding. And again, come to the Python tutoring session. Last week was a really good session, a lot of good questions, and we were able to, handle those, right online. But the earlier you can get us those questions, the better we can provide, examples. Elizabeth, I notice you're here. Anything that has come across your desk, everybody knows Elizabeth Lyon is the TA for this class and kind of the facilitator. And she's been doing this with me for a couple of years now. So is very knowledgeable about this as well. But Elizabeth, anything from you that you're seeing from students or areas that need greater definition?
Nothing from me so far. I did get a few questions this weekend, but I think you covered them already. But that's mostly it. But this is a fun assignment though, because I think it's really interesting how much information can be pulled from a single JPEG. So I hope everyone has a lot of fun with it. And if you guys have any questions, like Professor Hosmer was saying, please send it to us by Saturday or Monday.
Great, thank you. Yeah, definitely reach out. We love to do the tutoring sessions and the office hours to dig deeper into this, especially this gives you an opportunity over the weekend to, experiment with this. And as you run into issues, try to be as specific with those questions as you can. And then we'll try to come up with a generic solution that doesn't solve the assignment for you, but get you through whatever trouble spots that you run into. So. All right, well, gone. So have a great rest of the week. And thanks for coming tonight, and look forward to seeing you on Saturday and Monday, and we'll go from there. Have a good night, everybody.
Thank you.
Thank you very much.
Thank you.
Thank you.
Welcome.